Dear Facilitators International Study Channel followers, how are you? Welcome to Facilitators International Study Channel Grade 12 Mathematics lesson in Ethiopian curriculum. My name is Yamata. If you're interested in my presentation, you can subscribe, comment, like, and also share. Now, let us start our today's presentation. So our today's lesson is the least upper bound and the greatest lower bound of the sequence. So we have seen before that the meaning of and the example is the property of the upper bound and the lower bounds. So we can say now we can take out the least upper bound. From the upper bound, what will be the least, and from the lower bound, what will be the greatest one? We will see later on. Meaning is that the least element here. The least element from the set of an upper bound is the least upper bound, or we can abbreviate it here, which is a least upper bound of the sequence least upper bound of the sequence and also the greatest lower bound, the greatest lower bound for the set of the lower bound is the greatest lower bound, which is abbreviated greatest lower bound of the sequence. ምንድነው የሚለው ሊስት ኤሌመንት ብለን የምንጠራው ሊስት ኤሌመንት ከአፐር ባውንዶች ውስጥ we have a sequence or a set. From that set we have to have an upper bound. From those upper bound, the least element, which is known as the least upper bound, LUB. The least upper bound. From the upper bound, the minimum one. From the upper bound, the least one. We call it the least upper bound of the sequence. And the element, which is the greatest lower bound, the greatest element. For the set of the lower bound is the greatest lower bound of the given sequence. Lower bound, which is the greatest element or number, which is known as the greatest lower bound of the sequence. Now, when you come to the formal definition of a sequence, which is the least upper bound and the greatest lower bound, we can say let an be sequence of numbers, sequence of numbers. We can say let n be a sequence of numbers, and the first one in x is said to be the least upper bound, the least upper bound, the least upper bound of the sequence A, the sequence an, if first part here, if x is an upper bound, x is an upper bound of the sequence an, and secondly, whenever y is an upper bound of the sequence an, then we can conclude that x should be less or equal to, say, y. Which means that we can observe that let n be a sequence of numbers. Our intention is that, what does mean the least upper bound? Because if there is a number which is a least bound, there is also another least bound. So what would be the least upper bound? So x is said to be the least upper bound of the given sequence n. So the first part, if x is an upper bound, x should be an upper bound. Whatever y is an upper bound, when you compare x and y, so y is also an upper bound, x is also an upper bound. When you compare that, is x is less or equals to y, so x is the least or the minimum from those upper bounds. We can say x should be the least upper bound of the sequence, provided that y is an upper bound, so x is less or equals to the value of, say, y. Second example says that, second definition says that, the second part, the greatest lower bound. So x is said to be greatest lower bound. So if x is said to be the greatest lower bound of the given sequence n, so we can say the first part is if x is a lower bound of the sequence an, and whenever y is a lower bound, y is a lower bound of the given sequence an, then we can conclude that this, if x is a lower bound, and also whenever y is also a lower bound, and then x should be greater or equal to, say, y. To be x is the greatest lower bound. So whenever y is a lower bound and also x is a lower bound, so x should be greater or equal to y. We can say the value of x is said to be and sequence አለን የዛ sequence x የተባለ set of numbers greatest lower bound ነው ብለን የምንጠራው መቼ ነው የሚለውን ነገር ነው። ያ ማለት x ራሱ የሎወር ባውንዱ አካል ነው። whatever here y ሌላ lower bound ቢኖረን እና x እና compare ስናደርግ x should be greater than or equals to y ከሆነ so ግዴታ x is the ከሎወር ባውንዶቹ the greatest y ብለን መናገር መጥራት እንችላለን ማለት ነው። Now let's see some examples. Find the greatest lower bound, or the least upper bound, least upper bound, and least upper bound. That means least upper bound and greatest lower lower bound, greatest lower bound for each of the following. Look, the first part is let's say the sequence 1 over n, and the second part is B part. Let's say the sequence is say minus 1 over 1 the power of minus 1, the power of n, and the third 1 minus 1 over n, and the fourth one, say 1 minus negative 1 the power of n over n, we can say. Now we can determine, if possible, the least upper bound and the greatest lower bounds of the sequence. Here, as a solution, let's see this solution by listing some the terms. First, some terms of the sequence. We can say we have to have here so let's see sequence. Some few terms, first few terms. And the least upper bound, and the greatest lower bound of the given sequence. Look at this class. So the first part is a part, the sequence an is equal to simply 1 over n. So the first few terms are here, if operating the number starting from 1, the first part is say 1, the next part is 1 over 2, and 1 over 3, and 1 over 4, and also continue in such a way. When you observe this, it decreases to the number which is say 1. So the number which is say 0. The number which is, it decreases to what? 0. As n becomes larger and larger, the value of n decreases to what? 0. Therefore, from this part, the maximum, the set which is an upper bound, the upper bound is say the number which is say from 1 up to say infinity. 1 up to infinity is an upper bound, and the number from 0 up to say negative infinity is the lower bound, Now from this upper bound, the minimum, the least one becomes what? The number 1. So what we call least upper bound. To be the least upper bound, first it should be, the number should be members of the upper bound. From that, the minimum one is the least upper bound, so that 1 is the least upper bound and the number 0 is the greatest. So the from 0 up to negative infinity, is the lower bound. From those lower bounds, the greatest number becomes say what? 0, so that 0 becomes the greatest lower bounds of the given sequence. When you come to the second example, which is say B part, B is equals to simply B part, an is exactly equals to minus 1 the power of say n, minus 1 the power of n. So if n is 1 becomes say minus 1, if n is 2, 1, if n is 3, minus 1, if n is 4, which is say 1, and it continues in such a case, which is minus 1, 1, minus 1, 1, minus 1, 1. So that here, which way is it's not increasing, it is not decreasing, rather it simply oscillates. It oscillates between 1 and negative 1. So that the upper bounds are the number which the sequence here. This sequence is bounded from minus 1 up to say 1, minus 1 up to 1. The number from 1 up to infinity is an upper bound. The number from minus 1 up to negative infinity is the lower bound. So from the upper bound, the minimum number is 1. So that we can say 1 is the least upper bound. From the lower bound is the largest, the maximum number here it is -1, so 1 is the greatest lower bounds of the given sequence, even if it is not decreasing or increasing. Simply it oscillates between say -1 and 1. Another part which is C part, which is the sequence an is exactly equal to say simply 1 minus 1 over n, 1 minus 1 over n. If you observe here, if n is say 1, becomes the value which is say 0, because 1 over 1, which is 1, 1 minus 1 is say 0. If n is say 2, which is 1 minus 1 over 2, so the result is 1 over 2. If n is say 3, 1 minus 1 over 3 becomes say 1 minus 1 over 3 means which is 3 or 3 2 over 3, 2 over 3. If n, the value of n is 4, so 1 minus 1 over 4 becomes 4 minus 1 is 3, 3 over 4. The value is 3 over 4, and continue in such a case, which is 0, 1 over 2, 2 over 3, and also say increases. This increases. So when you observe here, 0, 1 over 2, 2 over 3, 3 over 4, and continue in such a case, so it also increases, but whatever it is increases does not greater than 1, because at the value of n becomes larger and larger, this becomes say 0, so the value becomes say 1, so the maximum number here is say 1, so it increases to 1. In this case, this sequence is bounded between 0 and 1. 0 and 1 in a sense, the sequence is bounded between 0, 0 and 1. So the upper bound is from 1 up to infinity, from the lower bound is from 0 up to negative infinity. So that we can say 1 is the least upper bound of the sequence, and also 0 is the greatest lower bound of the sequence. Meaning is that from the lower bound, 0 is the greatest one, or the greatest number. From the upper bound, meaning from 1 up to positive infinity, so 1 is the minimum or the least one of the sequence. Therefore, we can say the least upper bound is 1, and the greatest upper bound is the greatest lower bound is 0 for the sequence n equals to 1 minus 1 over n. n is exactly equals to minus 1 minus, or simply 1 minus 1 the power of n over n, over which is n. But this is simply rewrite as a sequence. If n is odd, say for example say 1, this is negative, so minus which is positive, so we can say simply 1 plus 1 over n. If n is odd, if n is even, if say for example 2, so minus 1 the power of 2 is positive, so 1 minus 1 over n, so simply 1 minus 1 over n if n is even. If n is even, meaning that here in the values are few terms. If n is odd parts, say 1, 3, 5. Say for example, if it is 1, so which is 1 plus 1 over 1 is 2. If n is 3, if the value of n is 3, 1 plus 1 over 3 is simply 4 over 3, which is 4 over 3. If n is 5, which is 6 over 5, which is 6 over 5, and continue in such a case. For all even parts, if n started from 2, 1 minus 1 over 2, simply the value which is 1 over 2. If n is 4, so 1 minus 1 over 4, so the result becomes which is 3 over 4. If n is 6, which is 1 minus 1 over 6, so the result is 5 over 6. Meaning is that if n is 1, which is 2, if n is 2, 1 over 2, which means the first part is decrease to what? Decrease to 1 over 2. So it becomes from 2 up to 1 over 2 decrease. And again from 3, which is increased to 4 over 3 and decreased to 4 over 3 over 4. And also in such situation, which is it oscillates. It's actually it's not oscillate, rather it is some increases, some decreases, but it is not increasing uniformly or decreasing uniformly. So we cannot determine the value. When you observe here, we have to up to 1 over 2 and 4 over 3 and 3 over 4, 6 over 5 and 5 over 6, and continue in such a case. Look, now we want to see the some upper bounds and the lower bounds for these sequences. The number from this or group of numbers, this is the maximum number, whereas this one is the minimum number. So all these numbers is inside here. Therefore, we can express which is 1 over 2 is less or equals to n is simply 1 minus 1. The power of n over n is less or equal to simply the value which is 2. Hence we can observe that here the number which is 2 up to positive infinity is an upper bound. The upper bound. Therefore, the least upper bound of the sequence is of the sequence an is simply 2. And also from this, which is the number from 1 up to 1 over 2 to negative infinity is which is the lower bound. From this lower bound is the maximum number. What you call the greatest number is 1 over 2. So the greatest lower bound of the sequence an is simply 1 over 2. Therefore, the least upper bound is 2. From the upper bound, the minimum one, the greatest lower bound is 1 over 2 of the given sequence in such a way as rearranged after piecewise form of the sequence. Now, this is the end of our today's presentation or lesson. The other day we will see the monotonic sequence, or the sequence which is increasing or decreasing. Still now, bye-bye.